and welcome to another session of Stop, Look, Listen, and Learn. Today we're going to be discussing time value of money concepts. Time value of money is something that's very basic to finance. It's one of the pillars that supports the entire foundation of finance. So as a result, you need to be very comfortable dealing with these concepts. So today what we're going to do is go over the basics to make certain that you're comfortable computing present values, future values, effective annual rates, the number of periods necessary to reach a certain goal given a certain interest rate and a certain compounding period. So we're going to discuss all of those things because you need to be able to work with these concepts very quickly and confidently in order to be successful on the exam. So I thought it would be good to get started by looking at an example that I think will demonstrate the importance of being able to work comfortably with these concepts. So let's assume that you have a situation where you have inherited, say, $1 million, and you want to invest a portion of that, but you want it to be relatively safe. So you do some research and you contact 3 or 4 different banks and you talk with them about the various deposit products that they have, certificates of deposits. And say you look at bank A, B, C, and D. And each one of those banks will have, say, a different compounding period. And so your goal is to maximize the amount of income that you get on your investment while maintaining the relative safety of the principal. So let's kind of come up with the facts here. So let's look. So we got 4 banks, let's say. We got bank A, we got bank B, and we got bank C, and let's say we have bank D over here. Now in terms of the interest rate, we're gonna say each bank is gonna pay 8%. To start off, keep it simple, each bank is gonna pay 8%. So each one of the banks are comparable in terms of the rates that they pay. But now we're gonna look at compounding frequency. And compounding frequency is important because it tells you how many times per year the interest will compound. And for bank A, let me just create a little bit of space here. So bank A, we're gonna say is 8%. And we're gonna say bank A has a compounding frequency that is annual. Sorry about that. And that means that the interest at bank A will compound only once per year. And bank B is going to be semi-annual. And bank C, we're going to say that bank C's compounding frequency is quarterly. And then bank D's compounding frequency is going to be monthly. Now we're going to further assume that the amount of your investment, you inherited $1 million, but you want to invest, say, 200,000 of that, which is 20% of the total. You want it to be in something relatively safe. And so we're going to invest 200,000. Let's see, we want to invest 200,000 in each one of the banks. Okay, so now what we're really interested in here is how much money you would have at the end of the year. We're going to assume that you're going to be investing in a 1-year CD, and it's going to pay an interest rate, a nominal interest rate of 8%, and these are going to be the various compounding frequencies depending on whether you go with bank A, bank B, bank C, or bank D. So the question is how much will you have at the end of 1 year? And you're gonna have a certain amount. If you went with bank A, you're gonna have a certain amount if you went with bank B, if you went with bank C, and if you went with bank D. And so one of the things you have to be able to do is to determine what those amounts would be. And so we're going to go through each one just so that you can get a sense of how to compute these amounts so that you can compare these banks and decide which one would be the one to go with based on what your goals are. So we're going to start off with the general formula, and I'm going to write it over here. So it is going to be future value. It's going to be equal to the present value, and it's going to be times 1 plus R. We're going to say R is the stated rate in decimals, divided by M, and M is going to be the number of times that the interest is compounded per year. Or in other words, M is going to be the compounding frequency, so I'll just put an M there so you know what that is. And then we're going to close parentheses. Then we're going to raise this factor here to the M. That is the number of times that the interest is going to be compounded per year. And we're going to multiply that by N, and N is going to be the number of years. Now, in this case, N is going to be 1, right? So, excuse me, what you may want to do is write down this general formula here, because this is the formula that will enable you to compute everything. So, I would say that you should memorize this formula here and be very proficient at using it, because if you're giving any 3 or 4 terms, you can solve for the one that is missing. So let's first look at bank A here. So we want to figure out what the future value is going to be, and we're going to put $200,000. That's going to be the present value. That's the amount we're going to invest today. That's the present value. And at bank A, we're going to get a stated rate of 8%. And remember, you always write this in decimals, so it's 0.08. And it's going to be compounded 1 time per year. That's the annual compounding. And M is going to be 1, and then it's going to be invested for 1 year. And so let's figure out what that amount turns out to be, getting out your calculator. So what you would do is you would do the inside first. So you want to follow the operations of mathematics. You may have recall the acronym PEMDAS from grade school, which stands for you do what's in parentheses first, then you do exponents, then you do multiplication, then you do divisions, then you do addition and subtraction. So those are the order, that's the order of operations. So we're going to start off with 0.08 divided by 1 is 0.08, and then we're going to add 1 to it, and then we're going to raise it to the first power, so we get 1.08, and then we're going to multiply that times the amount that we invest. And so what we see is that at the end of 1 year, if we go with bank A, we'll end up with $216,000. That would be our future value if we go with bank A. And hopefully everyone can see how we got that. So again, the present value is the amount that we're investing right now today. The stated interest rate at bank A is 8%, and it's going to compound annually, which means it's going to compound 1 time per year. So M is going to be 1. And so M goes up here in the exponent, and then we're investing for 1 year. We're assuming that it is a 1-year CD, so 1 times 1 is 1. So essentially what you get is a factor of 1.08 times 200. So at the end of the year, you're gonna have $216,000, right? So pretty straightforward, nothing, no fancy there. So let me move this out of the way so hopefully you can see that, and just jot that down, and then I'm going to erase it, and then we're going to look at how much you would have at the end of 1 year if you invested with bank B. I'll leave the general formula up here. Okay, now if we invest with Bank B, now Bank B is paying a stated rate. Well, first of all, we're going to invest the same amount, $200,000 in each case. And Bank B is also paying a stated rate of 8%. And again, we write that in decimal form. Now, Bank B will have semi-annual compounding, which means that the interest will compound twice per year at Bank B. So M is going to be 2, and then we're going to put a 2 in the exponent, and then we're investing for 1 year, so N is 1. So now, getting out the calculator to compute this, so we're going to start off with what's in parentheses first. So we got 0.08. We're going to divide that by 2, and then we're going to add 1 to that, and then we're going to raise that to the second power. And so we'll have the factor, and then we're going to multiply that factor by 200,000. And then we are going to end up with the future value of $216,320. That's if we go with Bank B. Now, what you should notice right away is that by going with Bank B, you're going to end up with $320 more than you would end up with if you had gone with Bank A. And that $320 differential is attributable to the compounding period. In other words, at Bank B, the interest is going to be working harder for you. That's one way to think of it. It's going to be compounding twice per year instead of compounding only once per year. So that means you're going to end up with $320 more. So you'll be taking essentially the same amount of risk, because we're assuming these banks are all insured, and you're getting the same rate, but the compounding frequency is going to be greater. Therefore, you're going to end up with more. So take a moment to jot that down, and then we're going to look at what you end up with if you go with Bank C. And I'm doing it this way just so you get a lot of practice working with this formula, because you really need to develop a proficiency with this formula, because this will pay rich dividends on the exam if you are able to work with this formula and rearrange it and manipulate it and solve for the various components of this formula here, right? So now we're looking at Bank C. So we want to know what the future value is going to be. Again, we're putting in $200,000. That's what we're putting in all cases, and 1 plus. And again, Bank C is paying 8%. That's the stated rate, putting in decimals. Now, Bank C, their interest compounds quarterly. So M is going to be 4 here. And then, so that's a 4 in the exponent. And again, we're investing for 1 year. N is 1 in all cases. So now we have that. And what we want to do now is compute what the factor will be. So, start off with 0.08, and we're dividing that by 4 because it's being compounded 4 times per year, and then we're going to add 1 to it because we do what's inside the parentheses first. And then we're going to raise this to the 4th power, and then that will give us our factor, our future value factor. And then we multiply that times the amount of our investment. And we end up with, let me just go with a different color here, since this black one seems to be running out. Just switch to blue real quick. So we have a future value that is equal to $216,486.43. Now, what you should notice here is that when you go with Bank C, you end up with more money than you got when you went with Bank B. And when you that when you went with Bank A. So here at Bank C, you're getting $216,486, whereas when you went with Bank B, you got $216,320, I think it was. So you're getting more money. So as you can see, what is happening here is that for a given stated rate, as you increase the number of compounding periods or the compounding frequency, you end up with more money or greater future value at the end. So take a moment and jot that down, and then we're going to do D. Now, here, we're looking at Bank D. We want to find the future value. So again, we're putting in 200,000. And D has given us a stated rate of 8%, again, in decimal. And it's paying monthly, so it's going to be divided by 12, because there are 12 months in a year. And then in the exponent is going to be 12, because M is 12 and N is always 1 in this case. And so now what we do is compute what the future value factor is. So we take 0.08, we divide that by 12, and then we add 1 to that, and then we're going to raise that to the 12th power, 12 times 1. And that's going to give us our future value factor, and we multiply that by the amount of the investment. And as we can see here, when we do that, the future value that we're going to get here is going to be $216,599.90. So as you can see, if you go with Bank D, you're going to have more money than you would have if you went with Bank C, B, or A. And that's because of all the banks here, D has the highest frequency of compounding. So that means that the interest at Bank B is going to be working harder for you than the interest would be working for you at Bank A, Bank B, or at Bank C. And so your goal is to go where the interest is going to work the hardest for you, or in other words, go where the interest is going to be compounded the most or the largest number of times per year. Now we can go on and make this daily, and it'll be a little bit more than that. And what we would do there, we would have 0.08 divided by 365 and add 1 to that. And then we would raise this to the 365th power to get the future value factor. And then we multiply that by the initial investment, and that'll tell us what we will end up with at the end of 1 year. Now, these compounding frequencies that we went over, these are referred to as discrete compounding. Now, there's another area, and that is continuous compounding. So you have discrete compounding, and then you have continuous compounding. So I'll wait a moment for you to copy this down or take a snapshot of the screen, and then we'll go through continuous compounding. Okay, so I'll kind of leave that up there, and I'll leave this formula here, and then I'll just make a note that this is for discrete compounding. Discrete compounding, that would be what the formula would be, and that's the most general way you can state that formula. This formula here will always get you what you need. Now we're going to go over here, and we're going to have continuous compounding. Now, with continuous compounding, the formula is going to be, let me just switch colors here again, try to make it consistent. So the formula is going to be future value, then you have present value, and then it's going to be E to the RT. When you go to continuous compounding, you get Euler's number, which is this E, and you're going to raise that to the rate, the stated rate that you get in decimal form, and you're going to multiply that by the period. Excuse me. So in this scenario, we're investing for 1 year, so the period would be 1 year, right? If we were, and that's for, yeah, so that would just be for 1 year. If we were investing for 2 years, it would be 2. If we were investing for only 6 months, it would be 0.5. If we were investing for only a month, it would be 1/12. So you get the point. So what this is saying is that if we go out, say we had a bank E here that was compounding daily, so that's 365. Now what he is saying is you're compounding every single second, every single half second throughout the entire year. So you're compounding an infinite number of times. And in calculus, when you do something an infinite number of times, you approach a certain limit. And the limit that you approach as the compounding frequency goes to infinity is this number here, E. And you need to be very comfortable with working with E. And that's on all of your calculators, right? So let's look at how much we would have if we went, let's say we went with a bank E here. Let me just put a different color here just to signify that this is continuous compounding. Let's say, so we have bank E here, and they said, we'll give you a stated rate of 8%, but our compounding frequency is continuous. Continuous, right? We're gonna put the same 200,000 in there. Now, how much would we have? So, future value is what we're trying to find. I put P here, but this really should be future value. Didn't mean to confuse you there, so let's just keep, present value, so let's just keep everything constant. So hopefully you can see that. So the present value, and sometimes see present value and P, principal, use synonymously. So the present value here is the 200,000 that we're investing, so it's gonna be 200,000. That's gonna be times E. Now, the stated rate bank E is giving us is 8% as well. So we write it in decimal, and then we're investing for 1 year, so T is gonna be equal to 1. And now we wanna figure out what the future value is going to be. We get our calculators. So we, here we wanna start off with the exponent, right? Remember the order of operations, PEMDAS, so you do what's first is in parentheses. Well, there's no parentheses here. Then the second order of operations is exponent, so we want to start with exponent. So we're going to have 0.08 times, hold on, let's see, 0.08 times 1, so that's 0.08. And then we're going to raise E to that power. So on most calculators, you gotta hit the second button and find the E to the X and hit second and then hit that number there. And then that's gonna give you that factor there. And you're gonna multiply that times the present value. And what you see here is you're going to get $216,657 and 41 cents. And you'll note that that number is larger than all of the other numbers that we previously computed here. So this would be at 8% for 1 year, this would be the maximum amount of interest that you would earn. It would be $16,657.41. You wouldn't be able to get any more interest than that because you can't compound any more frequently than continuous, right? So what that basically means is if you were faced with all these options here, you would pretty much go with bank E. I mean, it's a no-brainer, right? Because you're gonna get more, or you're gonna get the most amount of interest if you go with bank E. Now, that's pretty straightforward. Now the question becomes, let's say you inherited the $1 million, you decided you want to invest $200,000, right? And you done some research and say you came across A, B, C, and D, you didn't know about E, and you kind of like the people at Bank C, so you say, I'm gonna go with bank C, and plus you get quarterly compounding. But then let's say your spouse has a childhood friend who works, say, at bank A. And that friend of your spouse's is really trying to grow his or her business. And so your spouse comes to you and say, well, I really want you to invest the $200,000 at bank A so you can help my friend out and help him or her out in terms of building their book of business. And you say, okay, well, you know, if I go with bank C, they're doing quarterly compounding, and we're gonna end up with whatever amount we came up with. That's how much the future value is going to be if I go with bank C. Well, if I go with bank A, am I gonna be any worse off? Well, yes, if you go with bank A and the stated rate is the same, and let's assume that the stated rate is the same, and the annual compounding is the same. So if you go with bank A, you're gonna end up with less money at the end of 1 year than you would have if you went with bank C. So what are you to do? You wanna make your spouse happy. So one solution to the problem is to go to bank A and say, okay, I have an offer at bank C, they're gonna pay me 8%, I understand you're paying 8% as well. They are going to compound their interest quarterly, so their interest is gonna be working harder for me than the interest at your company. So can you change your compounding frequency from annual compounding to quarterly compounding? So your spouse's friend's response is, well, no, I can't change the compounding frequency because that's something that's set by the board. But I do, however, have some discretion in terms of being able to set the stated rate. So I can increase the stated rate above 8%. So the question is, if she or he is able to increase the stated rate while keeping the annual compounding the same, what stated rate must bank A offer to you so that you will be in the same position that you would have been in had you invested at bank C and got an 8% stated rate with quarterly compounding? So that's something you gotta be able to do. So you gotta be able to move back and forth between compounding frequencies and figure out what is the effective annual yield, if you will. And so that's what we wanna look at now, right? So take a moment to jot this down, and I'm gonna create a little bit of space here so we can do the calculation. So just going to erase this here just so we can get a little bit of space to work with, and I'm assuming you all had a chance to jot down the formula here. So essentially what you're going to do is you're going to say, all right, if I go with bank A, I'm going to get 0. Well, no, so what you want to say is go with bank A, you're trying to figure out what stated rate bank A must offer you if their compounding is going to be annual, so that you would have the same amount of money you would have if you went with bank C. So we're gonna have the rate divided by 1 because M is 1, and so it's gonna be 1, M is 1 times 1 year, right? And R is what we're trying to solve for, and we go with bank C, we're going to have 1 plus 0.08 divided by 4, and M is 4, so that's gonna be 4 times 1, right? Now let me just make this a little clearer so that if you're taking notes, you can see that. So it's gonna be 4 times 1. Now notice you got all numbers here, so you can compute what that is. So let's do that now. So 0.08 divided by 4, I'm gonna add 1 to that, and then we're gonna raise that to the 4th power. And so that's going to give us a factor of 1.0824 out the 4 decimal places. right? So now we're gonna have 1 plus R, and since it's 1, so I'm just gonna write that as R, because anything divided by 1 is just itself. So it's just gonna say 1 plus R raised to the 1, and that's what that is equal to. So let me just write that a little bit closer so you can see 1 plus R is equal to this number here, right? Now we wanna solve for R, so we wanna isolate R. So we're gonna subtract 1 from both sides. So we're going to get R is equal to 1.0824 minus 1. So that is going to be, and then we subtract 1, so that's gonna be 0.0824 or 8.24%. So I claim that if your spouse's friend can set the rate at 8.24% and keep the compounding frequency constant at 1, then you would be in the same position that you would be in if you invested with Bank C at 8% compounded quarterly. So let's test that out and see if that is correct. So let's come over here. So if we say, what's the future value is going to be? So this is going to be A. And we're going to invest 200,000, and we're going to get a rate of 0.0824 divided by 1, because remember that she can't change the compounding frequency. And so that's going to be 1 times 1, which is 1. So now the future value is going to be, so that's simply going to be 1.0824 times 200,000. That's going to give you $216,480. Now, let's see what you would get if you went with Bank C. Future value is going to be 200,000 times 1.08 divided by 4 raised to the 4 times 1. So let's figure out what that factor is. So that is 0.08 divided by 4 plus 1, and then we're going to raise that to the 4th power, and then we're going to multiply that by 200, and that's going to give us 216,000, it says 486.43. Now the difference there is just rounding. Probably should have taken that out to more digits or whatever, but essentially 480 and 486, are you going to be in roughly the same position that you would be in? That difference there is just attributable to rounding. If you expand the digits to 7 or 8 places, then you would end up with the same amount. So one thing to note here, and I want you to write this down in your notes, is this 0.824%. This is referred to as the effective annual rate. Now, what that means in English is, if you're comparing 2 investments like we just did here, the investment at Bank A and the investment at Bank C, and the compounding frequencies are different, then if you go with Bank C, you're going to get a certain amount of money in 1 year based on their stated rate and their compounding frequency. If you want to find out what rate you have to earn over that same year, 1 year period, if the compounding frequency is annual, or in other words, is compounded only 1 time per per year, what rate must you get in order to end up with the same amount of interest you would end up with if you went with the higher compounding frequency? That rate, which we just found, is referred to as the effective annual rate. And as you can see, as the compounding frequency increases, the effective annual rate will increase as well. If we were to do the calculations, I'm not going to do it here, and this will be a good exercise for you guys to go through. If you went with Bank D, they're compounding everything monthly, so a good exercise for you to do is to figure out what the effective annual rate would be that Bank A would have to offer you in order to put you in the same position that you would be in if you invested your money with Bank D. So those are the types of calculations that you need to be able to do on the exam. And so what I would encourage you to do is really memorize that formula, and I'm gonna give you a moment to copy this down, and I'm going to erase it and I'm gonna show you the formula again in different versions of it. So we got all this down, some working space here. Okay, we're gonna, on one side we're gonna have the discrete case. So here we'll have discrete. And I said the general formula is future value is equal to present value times 1 plus the stated rate divided by the number of times it's compounded per year raised to the number of times it's compounded per year times in the number of years. Now in here, in our example was 1, but n could be a quarter, in which case n would be 0.25, or n could be 18 months, in which case n would be 1.5. So whatever n is the number, how many years, and it could be more than a year, or a fraction of a year that you're investing. So that is the general formula there. Now, so you got this. Now, if you want to find the present value, so if you knew the future value, if you say, okay, well, I want to have $100,000 at the end of 1 year, and I can get a stated rate of 8%, that's compounded annually, how much do I need to invest today in order to get that 100,000? So you just basically manipulate this formula here. So the present value is going to be equal to, I'm just swapping everything, the future value divided by 1 plus R over M raised to the M n. So you just take this factor here and you divide both sides by that factor, and that will give you the present value. So if you plug in $100,000, the stated rate, the compounding frequency, the number of years you're gonna invest before you want to get the 100,000, that'll tell you how much you need to invest today in order to get it. Now, if we go over here to the continuous case, it says future value, present value times e to the RT. Now, it's the same thing. So if you want to know how much you need to invest a day in order to have a certain future amount after a certain period of time, then what you would do is you could write it like this: present value is going to be equal to the future value times e, and then to the minus RT. Write it like that. You can also write it like this: present value is equal to future value over e to the RT. Those two things are mathematically equivalent, so you can write it whichever way that you want to do it. Now on the exam, I think you might have to compute the effective annual rate like we did. You have to compute maybe a future value, you have to compute a present value. It's highly unlikely that you're gonna have to compute the compounding frequency of the number of years that it would take for an amount to grow to a certain period, if you will, right? And so I would get comfortable with these formulas. And then the last thing I want to go over with you is how do you compute the effective annual rate when you have continuous compounding. So you definitely need to be able to do that. So let's go through that. I want to make certain that you can do that. So let's say you have plus a rate that's, well, remember the effective annual rate, the compounding is always going to be 1 year, so we don't need to write that, so we just write R. 1 plus R, and then it's 1 year, right? And that is equal to E to the R T, right? Now, let's say you're gonna get a stated rate of 8% like we said in our case, so it's gonna be 0.08 times 1. So that's 1 plus R is equal to E to the 0.08 T, right? Which is 1, T is 1, so we can drop that, right? So just E to the 0.08. Now, what we wanna do is we want to solve for R, right? So what we do is we just say 0.08 and hit the second button, E to the X. That's gonna give us, this is gonna be equal to 1.0833, and then 1 plus R, and then get R by itself. This is 1.0833 minus 1. So the effective annual rate is gonna be 8.33%, right? And so that's how you would do it if you had a stated rate of 8% and it was compounding continuously, as in the case with Bank E, but your spouse wants you to go with Bank A, but they could only do annual compounding, then that means that Bank A would have to offer you a stated rate of 8.33% to put you in the same position that you would be in had you gone with Bank E and taking advantage of continuous compounding. So those are some of the basics that I wanted to cover today, and I would encourage you guys to work a lot of problems, memorize these formulas, commit them to memory, work a lot of problems so that you can get very proficient at using them and being able to manipulate them, and that will serve you well on the exam. And in subsequent videos, we'll go through how you use these formulas and these concepts when you have, multiple, cash flows and the like. If you have any questions, please drop them in the comment section, and I'll do my best to get back to you. And if you thought this video was helpful, also leave a comment or two to that effect, and don't forget to subscribe to the channel. Thank you and best of luck.